There he is.
All right. It's 2 o'clock.
Yeah, this stop working.
So apparently this is the new normal for a while. I think what I'm gonna do, I've been really messing around with this quite a bit, and I've already converted 2 of my classes, and I'll do the same this afternoon for this class. I'm gonna put this all on YouTube. So it's just too time consuming, and actually the streaming capabilities aren't quite as good in Ensemble as they are in YouTube. I mean, there's a noticeable difference. So I'm gonna actually put everything in YouTube, and there'll be like a playlist underneath a channel that you can go to and get all of the latest things. Does that make sense? So I won't post, just because it would take more than twice as long. I won't post any more videos in Canvas starting today, and I'll move everything over into YouTube. So that's like the major piece of information you're going to need. Yeah, I'll just name the playlist after the class itself, and then you'll be able to go there. And what I'm going to do, I mean, you guys are computer science people, so it's going to be like a stack. So whatever stuff happened chronologically, it's going to go like that. Does that make sense? So the videos at the bottom are the furthest back in time, and the latest ones are on top. Okay. Remember, you have a quiz due today. I think at some point next week, I'm gonna, like maybe Wednesday or something, I'll probably get I'm gonna send a test to you, and you'll have several days to work on that. So we'll have a test. And I'll give you various stipulations in terms of what you are allowed to use. It'll clearly be a lot more lenient than what I would have you do in person, but it is what it is. It'll work out, be okay. So I'm gonna open up the floor for questions. Any questions? Questions? Anything? And if you want to just type a question, you can, but if you want to just speak up and ask it, go for it.
How's the final going to look like for online now?
Well, that's a good question. We'll have to think about that.
All right.
But yeah, that's a good question. I really need to think that through. I don't know yet. But we'll see how this midterm goes. I'll like I said, I'll send it out on Wednesday. I have to think about how to craft it, and then I'll probably have a better idea of what might work for a final. What else? Other questions?
Are we gonna like review before the test?
Yeah, I mean, so, I mean, on Wednesday, I could, probably in Zoom, I could talk through some things, Of course, this is a time for you to ask any questions you want. I'm sure that some people will ask you know, things about like what the exam will be like, what might be on it. But again, you'll have lots of days to work on it. So it's a little bit different in the sense that you're not preparing for necessarily one moment in time anymore. Anthony's got his cat crawling around in front of him, so that's kind of cool. But yeah, we'll probably review in some way. The Bayes theorem stuff makes sense. Yeah. Yeah.
I do have a question.
All right, Peter.
So is Bayes' theorem different from the previous? Well, so what if it's L corresponding to D, or what is that? If A relies on B, I don't remember what that is. D.
A.
Yeah.
Okay.
So it's what's that called? I don't remember.
Conditional probability.
Yes.
Mm-hmm.
Huh. Okay, I don't know what. Yeah, conditional probability. So if A is conditional on B, how is that different from the Bayes theorem? So do you do the conditional probability and then Bayes theorem allows you to just flip it afterwards?
Yeah, Bayes theorem, you basically have a collection of information that involves some conditional probabilities in one direction. And you use that information, and incidentally, you have to know them all for like, you know, there's going to be a bunch of events that cover the whole sample space. Like it just breaks up the sample space. So if it's like people, then you have like men and women or something. Those are your two sets that cover the whole sample space, and they can't overlap, right? But you have some conditional probabilities in one direction, and the point is you can flip the thing around. That's what Bayes' theorem allows you to do.
Mm-hmm. So if you have the probability of A reliant on B, so that's
A
first,
conditioned on B, A given B.
Yeah. Then that's equivalent to probability of A and B over probability of B.
Yeah.
And then what does Bayes' theorem do from there?
Well, because you have, well, I mean, I could go over and do an example. So let me see. All right, let's see. Let me get rid of that. Let me, what do I want to do? I think I just want to leave it like this. Okay. Let me pin this so I can see what you're seeing. I'm going to pin this. Okay. So at the end of the lecture, I mentioned this example that involved a pregnancy test. Remember that? Like it was a pregnancy test situation. Let me revisit that example, and I'll kind of go through that more carefully. So let me just show you where Bayes' theorem comes up most frequently. It comes up in a situation where it's easy to compute the conditional probability in one direction just by gathering data, but then you really, when you execute the probability in practice, you really want it in the opposite direction. And the pregnancy test situation is exactly like that. Okay, so I'll go through that, an example, like fairly carefully, and we'll hopefully that'll give you a little bit more of a good footing with Bayes' theorem. Okay, so suppose I have a pregnancy test, and I want to see how accurate it is. Okay. So how could I test for the accuracy of that pregnancy test? Well, I could administer the test to a bunch of pregnant ladies. And what should happen like the vast majority of the time?
It should be true.
It should come back positive. Yes. So and I could actually collect data that would tell me what that probability was. I would be testing it on pregnant ladies. Okay. I would be testing it on pregnant ladies, and then those had better come back positive. The pregnancy test had better come back positive a high percentage of the time. Okay, so we could figure out the probability of being positive given that somebody's pregnant. Yes, we would know that. Okay. And by the way, I would also know the probability of negative given that someone's pregnant. Because what is that? Well, how would I get the probability of testing negative if someone's pregnant? What
It's
is
the opposite.
it? Would be 1 minus this. Again, if we're conditioning on being pregnant, then that's like the new sample space, and we can still do all of the normal, probability operations. So it'd be 1 minus the probability of being positive given pregnant. Okay, I would be able to compute that. I could also administer the test to non-pregnant ladies. You know what I'm saying? I could administer the test to not pregnant ladies. What would I? Okay, so pregnant, not. Okay, I'll put a little bar on there. That means not pregnant. Okay. What would I hope would be true here?
It's negative.
Yeah, that the test would come back negative. And I could gather data, and I would know what that is. And then, of course, you would also know the probability of positive given that someone was not pregnant, because that would simply be 1 minus the probability of negative given that someone is not pregnant. Okay, so I would have that. Okay. And I would also, in theory, just by gathering data, I could compute the probability. I would have access to the probability of being pregnant, for instance. Yes. Like I would have a good idea of the fraction of ladies that are pregnant, and then I would be able to figure out the fraction of ladies that are not pregnant from that, because that would just be 1 minus pregnant. Okay, so is it reasonable to you, hopefully, is it reasonable to you that I would be able to get all of these things just by kind of going out and testing the thing in the marketplace? Hopefully. And incidentally, I want to do all of this before I put the pregnancy test on the market. You understand? That's like the whole point of this. I don't want to like put a pregnancy test on the market that's going to be delivering incorrect information a massive proportion of the time. That would be ridiculous. I would go to jail. Does that make sense? Or something, I guess. Okay. So the whole point is I want to figure out how accurate my test is before I go to market. Okay. And by the way, the probability of positive given pregnant, that is called a true positive. Yes. That's a true positive. So that's a true positive. What is this called? Okay. Given that they're pregnant, the probability of being negative, what's that called?
False positive.
Well, not a false positive.
The true negative.
It's a false negative.
False negative.
Okay. What about the probability of being of testing negative given
True
their
negative.
What's that called?
True negative.
True negative.
True negative. Okay. And positive, if they're not pregnant, that is called a
False positive.
false positive. Have you heard terms like that before, maybe somewhere? Oh, that's a false positive, right? Well, that's the sort, this is the sort of situation from which that arises from, okay? So you're saying, what does this have, okay, what does this have to do with Bayes' theorem? Well, I'll show you, okay? And I'll write it over here on this side of the board. Look, when the test goes to market, you don't care about testing pregnant ladies anymore, like knowing that women are pregnant and telling us that they're positive. That's stupid. We already knew that. Does that make sense? Like, you no longer care about going to the pregnant ladies and having them take the test and it coming back positive. That's not what you want to do anymore. Now you have people take the test, and what information do you know now? Once they take the test, what will you know?
They're not pregnant or pregnant.
Well, no, you won't know that. What you'll know necessarily, hopefully you'll know that, but they'll take the test and it will come back either what?
Positive or negative.
You will know that it's positive or negative. And then you want to know, okay, I just got a positive pregnancy test. What is the probability that I am pregnant given that the test was positive? Do you see that that's opposite? That's like the opposite of this.
Yeah.
Here I was testing known pregnant ladies and getting the proportion of those that came back positive, yes?
Mm-hmm.
But when the test goes to market, they take the test and it comes back positive or negative. So then you know it's positive or negative, and you want to know, okay, well, what fraction of the time are they actually pregnant? Okay, so that's what Bayes' theorem is dealing with. So let me show you. So now we want the probability. It's like, hey, I just got a positive test, given positive, yes? And what do you want to know the probability of?
Are they pregnant?
Yeah, that they're pregnant. Okay, and here's what we do. So we know that this is equal to probability of pregnant and positive divided by what?
Positive.
Probability of positive. Make sense? And then we say, well, what's the probability of positive? I'm going to erase this stuff right here.
It's 1.
Well, no.
Oh, well.
So the probability, you say, okay, well, I have all those like conditional probabilities and stuff. I have this intersection up here. Can't I just say that this is, right, the top thing is just the, oh man, that's a huge fraction symbol. So it's going to be the probability of pregnant, which we had, yes? The probability of this intersection is the probability of being pregnant times what probability?
The probability of being
Yes.
pregnant conditional conditioned
No.
on.
Yeah, but it's
Oh,
going
no, the other way.
flip
Yeah.
around. It's going to be the probability of
Positive conditioned on pregnant.
positive conditioned on pregnant. And do I have both of these?
Yes.
Yeah. Now, what about the probability of positive?
It's 1.
How can I get the probability of positive?
We already know what that
You know
was
that to
before.
be. Yeah, don't you know that's true already?
No, well, yeah, but I need, right, but that, yes, because this is a conditional probability, but it's still sitting here in the denominator. I still have to compute it. Isn't the probability of positive equal to the probability of positive and pregnant plus the probability of what?
Not pregnant.
Positive and not pregnant. Make sense?
Yeah.
And then we say, oh, so this whole thing, here's this huge fraction symbol again. It's going to be the probability of being pregnant times the probability of positive given that you're pregnant. And on the bottom, hey, can't I do this? I know how to do this. I know how to do the probability of positive and pregnant. How did I do that again?
Positive. Of being
Of
pregnant.
times probability of
Positive or
positive given pregnant.
conditional.
Well, okay, which is exactly the same thing I had upstairs, right? And that's something that happens in Bayes' theorem. You always have one of the summands downstairs that's the same as upstairs. Plus, okay, so what's the second summand going to be? Probability of
Not pregnant.
not pregnant times the probability of
Not pregnant conditioned on, or no, positive conditioned on not pregnant.
yeah, positive conditioned on not pregnant. Okay, kind of ran out of room there. So the whole point is, look, going from the beginning, we can compute the probability of pregnant given positive. Let me just I'll write the formula here for us. The probability of positive given pregnant, pregnant given positive is equal to the probability of pregnant times the probability of positive given pregnant, which is the flip of this, yes? Divided by the probability of pregnant times the probability of positive given pregnant, which is just a carbon copy of what's up here, plus the probability, let me erase this, plus the probability of not pregnant times the probability of positive given not pregnant. Okay?
Dr. Hammond.
Yeah.
For the top, when you're using the multiplication rule, would you still have the equivalent thing if you use the other event first, like saying the probability of positive times the probability of pregnant given positive? Would that be the same thing?
Yeah, that would be the same thing.
I know it doesn't apply to this. I was just wondering.
Yes, that would be exactly the same thing. But in our case, it's wiser to use the other one, right?
Yeah.
It's wiser to use the other one because that's the information we actually have. Okay. So let's actually apply this. I want you to at least see some numbers here. Let's actually apply this. So suppose we go out. So does this make sense? This is an application. This is a typical application of Bayes' theorem. I have the conditioning going one way here, and I flipped it around on the right-hand side because that's the stuff I know. I'm getting a new conditional probability based on conditional probabilities that I have. That's the essence of Bayes' theorem. Now, suppose I tell you the following things. Suppose I say that the probability of positive, given that they're pregnant, we test our thing here, and the probability of positive, given that they're pregnant, ends up being, that comes back 95% of the time it comes back positive. That'd be pretty good, right? I guess. Okay. So suppose that I also discover that the probability of positive given that they're not pregnant, okay, I don't know. Let's suppose that happens like, 0.01% of the time or something. Okay. So, and this is another thing I would be able to test, right? I would administer the test to non-pregnant ladies, and I would just calculate the percentage of time that the test came back positive or negative. Yeah. And then what other information would I need? Like what other? What's that?
Probability of being pregnant.
Yeah, I don't even know what to guess for that. Shoot.
73.
What's that?
73%.
No. let's suppose it was like let's say it's 0.05 or something. Okay.
Well, how would you even find that? Because isn't that just like a percentage of women that are pregnant over the entire population of women?
Yeah. So I mean, you could. There's actually a bureau, believe it or not, that tracks something called vital statistics of life, and they can give you a pretty good idea at any given moment in time the percentage of women that are actually pregnant. I don't know what that is right now. I'm putting
Oh, okay.
5% there. Okay?
Wouldn't that be based on your sample space though? Not.
Well, but we're just imagining that this is, because you don't know who's going to take your test, Peter, right?
Okay.
So, you have to assume that any woman in the United States could take your test or something, right? So you have to assume that the population is all American women or something, okay? So let's see here. What would the probability? Okay, here's kind of the punchline. What would the probability of pregnant given positive end up being in this case? Well, this says up here, this says that to get that, I would need to take the probability of pregnant, which is 0.05, times the probability of positive given pregnant, which is 0.95, yes? Okay, and on the bottom, what would I have? Well, the same thing, 0.05 times 0.95 plus, okay, what's the probability of not pregnant?
0.95.
Yeah. 0.95, and then it would be 0.95, and the probability of positive given not pregnant, that was 0.01. Okay, now I need a calculator, right? Hang on. Okay, so 0.05 times 0.95 divided by 0.05 times 0.95 plus 0.95 times 0.01. I get 83%, 0.83 repeating. I mean, that's kind of surprising, right? Like, okay, I mean, think about it. That just shows you how accurate your test has to be. You understand? I just threw these numbers out there and they seemed fairly reasonable. Okay? But look, if I put this test to market, then someone testing positive, how often are they actually going to be pregnant?
80%.
83% of the time. So 17, like 1 out of every 5 women that test positive isn't even going to be pregnant. I mean, that's a garbage test. You know what I'm saying? So that just shows you how accurate these tests have to be at the beginning. By the way, there's been some massive mistakes made on this very issue in the past. It happened with early HIV tests. There was something called like the ELISA test for HIV that got people all freaked out, and they weren't even, a lot of people were testing positive. Can you see me?
Yep.
A lot of people were testing positive, and guess what? There was testing positive. It was fairly, it was a fairly low percentage of the time that they actually had the disease. Does that make sense? And it was a mistake in terms of thinking through, flipping around the conditional probability, that it was at the heart of the issue. Okay, so yeah. Does that kind of clear up some of your thinking on that, Peter?
Yeah.
All right. Other questions? Other questions? Some of you are being consumed by your cat fur. Those backgrounds kind of start crawling around the front of people sometimes.
I don't even actually own a cat.
Yeah. All right. What else? Anything else? Any other questions on Bayes' theorem? All right, so from today onward, it's going to be a YouTube paradigm in the stack format. And again, I'll go finish that off today, and I'll post a link to the playlist in YouTube, and you can use that instead of having to get into Canvas every time. I will continue to post course materials and grades and everything else in Canvas, and I'll communicate through Canvas. But as far as video content is concerned, I'll put that on YouTube.
Will you still be having Zoom meetings like this, like to answer questions?
Oh yes, still. Yeah, for sure. Yep. I want to continue to just run this format the way we have been. I think it's working all right, just based on feedback I'm getting. I mean, look, if you think this stinks, you just have to tell me, because I'm kind of going by the seat of my pants here. Look, I mean, if it stinks, you have to tell me either out loud right now, or you can email me and say this stinks, and I can change the paradigm. But if you stay silent, I'm just going to keep doing stuff that stinks. So as far as the course materials go, I'm going to keep doing the lectures, posting them on YouTube, and then we'll continue to meet in Zoom, and I'll hold my office hours Monday, Tuesday, Thursday, and Friday too, just so you can get questions answered there. Any other questions?
So you said you're changing over to YouTube videos?
Yep.
Okay, so the way you have it laid out right now in Canvas, where it's just like a link to each video, like that is super awesome. So just thank you for making that really easy to navigate. Would you be able to do the same thing with like links to the specific YouTube video, or are you just going to have one link to the whole playlist?
I'll have, okay. So, okay. So each class, so I have a YouTube channel, and it's called, there was, since it's a free version of YouTube, I had to name it after my own self.
Right.
So it's called Adam Hammett. And apparently there's a wrestler named Adam Hammett, but that's not me. But my channel is called Adam Hammett. And in each channel, I have a playlist. And I have the videos stacked chronologically like this. So like the very first thing I posted would be on the bottom of the playlist. I'm organizing it in that way.
Okay.
Does that make sense? So then I will actually put a link in Canvas to the specific playlist. When you go there, you'll see new content at the top of the list. One video stacked on top of another one. Does that make sense? Is that
yeah.
Enough, Timothy?
Yeah, cool. Thank you.
Yeah. And I'll have
the lectures. Sorry.
And I'll have everything dated so that you can see why it's sorted the way that it is.
Will the lectures be in parts like the first lecture, or will they be just one whole video?
With Zoom, it's so much easier to, and with YouTube, the other thing about YouTube as opposed to Ensemble, YouTube has massively easier tools to work with in terms of video editing. Apparently they stripped down what they had before, but what still remains is really pretty nice. So it's really, really easy for me to chop things out, trim things. So I don't really have to do that anymore. I can screw up as many times as I want, and I can just edit it out. So I'm probably just going to do one. That,
All right.
does that make sense?
Yep.
Unless I do just totally butcher it or something, which is entirely possible, in which case I would have to chop it up into a couple, but yeah. Okay, and I'll continue to post these as well for people that were unable to attend so they can get extra information if they see the need to do so. What else?
If an aircraft had a locator, why wouldn't you be able to discover it?
What? Say that?
If an aircraft had a locator, why wouldn't it be able to be discovered?
Maybe it broke.
Yeah, maybe it maybe the coronavirus like dissolved the locator or something. Who knows?
Malaysian Airlines Flight 370, that had a locator. That's gone. So
Oh, it did?
right, yeah, there was a black box on it, and the beacon worked for I think it was like a month, but then we weren't able to find it by the time that the battery died. So
Yeah, there's an awesome movie about the guys that about it's called Alive. It's this team of like I don't remember, like a international soccer team or something, and they crashed in the mountains, and there was a locator on that plane and they couldn't find them, so they were like just out there on this mountain for a long time. True story, kind of a gruesome story, but it's a really interesting movie. But yeah, apparently it happens. All right, well, hang in there. Hopefully things are going decently well for y'all. You know, feel really bad for the seniors, especially. It's kind of a bummer, but like Dr. White was saying, at least it'll be memorable and it'll shape you. So yeah. Okay. If not, there's nothing else. I'll sign off for now.
Thank you.
All right.
Thank you.
Have a good weekend, y'all.
Thank you.
yeah, you too.